Okay, so chapter 9 is all about area. Easy stuff, but there are some formulas that I want to review with you kind of before we get started. That's what 9.1 is about. It's about simple area formulas. Okay? 6 of them that we're going to talk about. Now, most of them are found in section 9.1, kind of scattered throughout. The pages in your book that they would be on start on page 589. Okay, so 589 is where you find most of these. I'm going to go in order that they are in your homework, so it might be a little bit easier for some of you. The very first one we have is a rectangle. You all know the formula for finding the area of a rectangle. Okay? Area of a rectangle is base times height, also seen as length times width. You have your height, you have your base, you can find the area of your rectangle by multiplying. Not difficult, write it down anyway so you have it. I want to know that you have it. Okay, next one, let's see what we got next. We got parallelograms. Okay, and in a parallelogram is just essentially a shifted rectangle, right? Like we could cut off a piece of a rectangle, do something like this, and just cut it off from there and slide that piece to the other side. Okay, that's how parallelograms are made. Now I'm going to get rid of this because we don't really need a triangle yet. But for a parallelogram, you have something that looks like this. Okay? Because it is just a shifted rectangle, its area is still base times height. The base is still the bottom part. Be careful though, because the height has to be perpendicular to the base. Write that down. The height, the number that we use for height, must be perpendicular to the base. If it's not perpendicular, it's not the height. Now in your packet, they're all laid out nicely for you, but you're going to have to be careful. You might screw some up in the future. Okay? So far, base times height, base times height. That's rectangle and parallelogram. Those are pretty similar. Okay, those are both found on 589. Getting to 590, we got a little bit more to talk about. Let's talk about triangles. Okay? Triangles. I'm going to put, I lost the T for me. There we go. Okay, I'm going to put 2 pictures on the board for triangles, because there's an important piece of information for triangles. Now, that whole idea of the height is perpendicular to the base shows up in a triangle. If you have a regular old right triangle, you have a base and you have a height. Not difficult. But what happens if your triangle looks like this? Not necessarily a beautiful right triangle. You still have a base, but the height has to be perpendicular to the base. So when we draw that height in, it's got to be perpendicular. This side here, not the height. This side here, not the height. The height must be perpendicular to the base. So this right here, we know it's a right triangle because that's what we're going to use for height. And it's perpendicular. So I'm going to get rid of those so you don't get confused. Now you all know this formula. Area equals 1/2 base times height. You know that. But remember, putting it up here again, you're putting it in your notes again. Height must be perpendicular to the base. So make sure it makes a right angle. If it doesn't make a right angle, don't use it. Please don't use it. Okay, so far out of those first 3, you probably know all 3 of those. They're not real challenging, and so I think you know them and you're going to be just fine. Okay, the next 3-ish are a little bit tougher, but you're going to get them figured out. But let's talk trapezoids. Okay, in a trapezoid, that's pretty good. That's the best trapezoid I've ever drawn. Okay, so here we go. So we got this trapezoid here. And in a trapezoid, you have 2 bases. You have the bottom base. I'm going to call it base 2. Goes on the bottom. And then you have a base on top. Now, it sounds funny to say that we have a base on top, but we have a base on top. Okay? And with that base that's on top, we call that one base 1. We're going to use both of them. You also have a height. The height must be perpendicular to both bases. There's the height. Okay? You're going to get sick of seeing this, but the height must be perpendicular to both bases. I'm going to underline both because it has to be perpendicular to both. Okay? If it's not perpendicular to both, once again, please don't use it. Okay? That doesn't necessarily mean that our triangle or trapezoid is isosceles, because what we know about trapezoids is that the top and the bottom are parallel. And since they're parallel, if it's perpendicular to one, it's perpendicular to the other. For a trapezoid, still using that good old 1/2 because it kind of looks a little bit like a triangle. 1/2 base 1 plus base 2 times the height. You may also see it written base 1 plus base 2 times the height divided by 2. Both are good for trapezoids. Okay? So, we've hit rectangles, parallelograms, very similar. We've hit triangles, trapezoids, very similar. Now we're going to talk rhombuses and kites, which are, again, very similar. Let's talk rhombuses first. For a rhombus, that is a quadrilateral, that is a parallelogram where all 4 sides are the same. Okay, that's a decent looking rhombus. In that rhombus, we have what are called diagonals. Okay. One of them is diagonal 1, D1. The other one is D2. No, just kidding. Diagonal 2. And in that, the diagonal is the length of the whole segment right there. Okay. The area of a rhombus is pretty basic. Think about what we talked about with rectangles. Picture yourself taking this piece right here and moving it. Picture yourself taking this piece and moving it. We end up with a rectangle. That rectangle has a base of D1 and a height of 1/2 of D2. So what we're going to do here, let's get rid of our little guys right here so we can see our original rhombus. Okay, is we are going to do 1/2 of that D1 times the D2. Not a bad formula. Plug and chug, substitute in and go. Okay. The same thing works for kites, right? Kites are a little different because not all 4 sides are the same. Kites have consecutive sides that are the same. Okay, but kites still have diagonals, even if this is not a good picture. And their diagonals, we have 1 and 2. And their formula uses those diagonals in the same way. So we've kind of paired things up. We have sorry. We have let me start from the top. We have rectangles and parallelograms that are the same. We have triangles and trapezoids that are the same-ish. We have rhombuses and kites, which are exactly the same. Okay, we have one last one to finish up, and this one you all know, so I'm not too concerned about you. The last one we're doing is the area for a circle. Okay? A circle. Orange. A circle. And in a circle, we have a radius. And of course, you all remember that the radius is 1/2 of the diameter. So if you're given a diameter, which you're not today, but if you are, remember, the radius is 1/2 of the diameter. Remember that, please. For area of the circle, we only use the radius. If you're given the diameter, you gotta be careful. We do pi because circles are pi. Pi times the radius squared. Okay, you have 7 formulas. You have a homework packet that's going to use those. The ones that are put together in the packet are the rhombuses and the kites. Okay? When you are doing these problems, please show your work carefully. Get in the habit of writing the formula down every time. Okay, so as you do problems, please, 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 please in all caps, please start by writing the formula. And some of you are going to go crazy when you have to do that. But as we get to harder problems, it will make more sense if you write the formula down. Thank you, because I really want you to do this. Okay? So you have problems to do on area, and you have this information to get you going on them.